I think to help limit the discussion, it'd be worthwhile defining what it is we're talking about a little better. So we're all, because even in the discussion we just had, you know, when people were putting out ideas, there's this mixture between, at least in my mind, there's a mixture between experiments that are really interesting scientifically and are research and cutting edge experiments and what's going to be the core. And as Jerry's pointed out, and it's also been pointed out a number of times, we all have to keep in mind this trade-off that's going to happen between the number of model runs we're suggesting for the core, the number of components that the model or groups are going to be able to put in, and how many ensemble members we're going to be able to run. So that trade-off is always going to be in the back of the discussions, sometimes maybe in the forefront of the discussions. And I think in the last IPCC we had prescribed something like 1,300 or 1,400 years of model integration. There were sets of idealized scenarios, and there were sets of historical forcings, and then future forcings.
Not including spin-up.
Yeah, that's all off the table for that. What was prescribed, how you got to the initial conditions was your own problem.
That's also without any ensemble. It's like one ensemble.
Yes, that was one ensemble of each run, one member of each run. So what's the model that we're envisioning then for these core AR5 experiments? What's it look like? And then how long?
Can I just ask a question though about that? I mean, it seems to me that certainly the modeling, everybody needs to be aware of that, and that there are resource limitations, and that some questions will be more amenable for intercomparison, kind of the core, as you call it. But at this point, isn't it still a little premature to truncate too much? I mean, I would rather see an open-ended discussion of what are the key questions that we think can be addressed, and then if we want to make the point that there's going to have to be distinction made.
I was afraid of going that route for the fear of not getting convergence. Because there are virtually an infinite set of interesting scientific questions that one can be asked with these models. These models are relatively new. There's only been a few groups running them, and I don't know if anybody's run them in the configurations that's being talked about here.
Maybe we can proceed by first discussing the core and then taking up Richard's question, see how one could expand it.
I think it'll come up naturally.
Yeah, I do too. I think that's fine. I just wanted to. It seems to me that that's, you know, and I understand the rationale, but at some level, it's premature, I think, to make those kinds of decisions, and not entirely.
I guess not from a modeling group perspective. I mean, I don't know. From the modeling groups, we're designing right now. The atmosphere model and the ocean models are, the grids and whatnot are being laid out. That process is on the way.
Yeah, but I assume that unless the core is, I mean, we won't know what the core is until that assessment starts, because that's when that decision will really be made. But I assume that each group is going to include some things that it feels it wants to do, whether or not it's in the core.
Agreed. We're not at this point. I don't think we should have any comment on those.
Well, other than the stimulating ideas.
Yeah.
That's all I'm thinking.
I mean, there's two dimensions to this whole issue of prioritising. One is about what we think is interesting scientifically.
Right.
Your article's on, that's an infinite number of questions.
Right.
And then there's another set of constraints which is about what's useful from a policy perspective. And I suspect the convergence of those two is actually quite a small number of experimental designs. I mean, I think if you keep in mind what policy driver is, then I think it limits quite a lot of your experiments in the core.
But is that true if some of these experiments are potentially having big impacts on the climate projection? Then that wouldn't be true. Right? I mean, if somebody does an experiment that's not in the core and they claim it has a big effect on the climate projection, that obviously has big policy implications.
And that's going to be part of the assessment of the next assessment. The lead authors will get to assess that result.
Yeah.
But I don't know how we can define.
Yeah.
I mean, we can't define that. In some sense, I was part of the group to define, in some sense, what the experiments were for this AR4. And it really, there's some judgment about what is a common group of things that a lot of groups can run.
Yeah.
Because you want to have a model in their comparison when you get done.
Yeah.
Well,
Yeah,
is
I suppose it's the scenario that is determined by what is policy relevant, right? And my suspicion is that by the time we get to AL5, there'll be much more emphasis on stabilisation on the longer time scale, which actually makes experimental design easier.
I think there's that aspect to it, but I would also argue that the historical runs are just as important for a lot of the.
Yeah, we can agree on those because there's only one history.
Well, in theory.
there's 216.
I've had a Russian colleague of mine saying the trouble is not just making future projection, but also making the
Agreeing on the past.
Yes,
I agree with
exactly. Yeah.
Well, okay, well, yeah, but to some extent, I mean, we could agree on what we think the best guess was for the historical forcing. If you do it,
So in the past IPCC, there was kind of the scenarios were up to 2100, and then there was this idealization that was made where the radiative forcing was held constant, which is completely crazy in any sort of science sense, because the aerosols would drop out almost immediately, and the greenhouse gases wouldn't. But to look at stabilization issues out to about 2300. One of the questions I guess I like to settle on is that timeline about right? Do we want to extend it? Want to shorten it?
2100,
2300.
2300.
2300.
For stabilization purposes.
Yeah.
I think that's right.
Most of the emission scenario modeling teams are now working to 2150 for the stabilization, but usually doing the calculation only to 2100.
Really?
And there's been some discussion of going a little bit beyond, but stabilization is usually pegged to 2150.
Right.
And
That actually will work out well
yeah,
from a modeling point of view.
150 years after that.
And so it'd be another 150 years of stabilization.
Yeah.
and three levels are usually considered right now. I don't know how that will change. One is the extreme low one of 3 watts.
Yep.
The EU directive in quotes.
What's that, roughly 450?
That's I think roughly 450 CO2 only.
Yeah.
Yeah. And then 4.5.
Yeah.
And 5 plus. These are the 3 categories that the modeling teams are working on. So I don't know how that.
You
We'll
said
get to the
that-
scenarios in a bit. but-
That's stable. That's stabilization with that added radiative forcing. Is that what I mean?
Yeah.
Okay.
Whereas the individual groups juggle the gases in different manners, and in particular aerosols.
You're forcing are relative to pre-industry.
Hmm?
That's relative to pre-industry.
That's relative to 2000.
Up to 2000.
No, wait a second.
No, it must
No,
be.
okay, it's got to be pre-industrial.
Pre-industrial. I'm sorry. Yeah, pre-industrial. Yes.
And we're already at what?
Yeah.
How many watts above pre-industrial?
2.
Aki, what are the 3 categories again?
3, 4.5, and 5 plus.
And watts per meter squared.
I guess there's been discussions in the MIT group there. I was wondering how useful the 450 stabilization really is, because it just seems
No way.
there's no way that
There
we're
is
gonna
no
get
way. I
to do
mean,
that.
if it's a multi-gas, you're talking about what 390 or something for CO2.
Well, the way that's
Well,
being,
overshoot.
it's treated through overshoot
Uh-huh.
usually, and then there are scenarios. I mean, you can say what you want about it, but the community is doing relatively unrealistic scenarios from my point of view, where you do lots of biomass scrubbing and storage, then you have actually negative emissions. So it's a little bit like the geoengineering in a different
Well, also,
disguise.
Sure, presumably if you do it in terms of radiative forcing, there is a possibility of doing a large sulfate cooling, right, to keep it.
That's,
Okay.
yeah, that's good. And that whole thing, you're assuming something for the indirect effect, which we have no clue
Yeah,
what it is.
exactly. That's where it comes from.
All right. I was ready to start down the list of questions.
Just a remark. If you're talking about very low stabilization, then what you do to aerosols and non-fuels become more important.
Well, I was good. Can we postpone? That's a good question. But then I was going to wait and when we get down to discussing the actual scenarios, it might be a question that doesn't have to come up, depending on what scenarios we choose.
Ron, going back to your question about the core, is a straw place to start off the thing that we sort of talked about yesterday? Our group yesterday tried to define what we thought the core was going to look like. Core model.
Go ahead.
Well, you all remember. We can give you handouts. I think. Feel free to help me. But I think that the main thing is that it was going to have some degree of gridded land use change, as well as just the emissions from land use, and some very simple, also a carbon cycle, and some very simple parameterization of succession that happens, post agricultural activities or post logging activities.
Post what?
Post logging or post abandonment of cropland. Those are things that are required for this sort of carbon cycle to become more realistic.
Sort of a follow-on to that, I guess, as far as one of the questions I have been interested in would be the relative of importance of the biogeochemistry on the forcing, like the CO2 forcing, versus the more biophysical bits of the albedo, because they tend to operate in opposite directions.
Well, I can just report that, for example, our group, and we are working on the emission side primarily, it's focusing exactly on those issues. Really at land use and trying to get a consistency across different land use categories, from agricultural to forestry and the other lands, which is quite a non-trivial matter. And we are gridding that together with the socioeconomic parameters.
I want to talk to you more about that offline.
And then overlaying on that the carbon cycle also.
Right.
Carbon balance, if you wish, or a carbon budget on the grid scale.
I think on the ocean side, we were saying that the core would have some simple ocean biology carbon cycle model of the NPZD class.
On the land use, including historical, right? So it has to be the whole smooth transition.
And what kind of classification in the land use? I mean, how detailed, or what sort of scheme are you talking about?
I think there'll be some variation there. I think it'll be the core will be very simple. So it'll have cropland, probably one or at most sort of two cropland types.
So but you will have different cropland types. That's interesting.
Well,
Well, actually,
whether they use them or not is another issue.
Exactly. I mean, you can't use. I mean, normally at least our group has many categories.
No, I know,
including the
climate.
inclination. So you have to somehow aggregate it to the useful categories for intercomparison.
Right.
I think there'll be some spread in models and how many different crop types they track.
Would grazing be included?
Grazing, that'll be on the pasture. So pasture, cropland, pasture,
Exactly.
and then forestry.
I was gonna say, as a general comment, I don't know how the rest of you would feel, but as somebody, I think, to design a core experiment, I would like the design to be able to be run by non-ESMs, because there are going to be groups that aren't going to have an ESM, and it'll be worthwhile to run whatever design we have. That people with the AOGCMs can run that same experiment.
I think
and
that's
participate.
I think that's pretty simple, because for those, what I would see them doing is using kind of very similar to the emission scenarios they get now, sort of.
Well, that's good. They don't use emission scenarios.
Okay, well, so
those runs need concentrations.
Okay,
So that's what is going to be an interesting question: is who or how translates emissions into concentrations. And that's all. Historically, that's been an argument inside the IPCC.
It's not a problem if you're doing stabilization runs.
Pardon?
It's not a problem if you're doing stabilization runs, is it? You're talking about concentration scenarios
On
or relative focus
the transient part is a problem, and once they're fixed, you're right, it's not a problem anymore. You just specify them.
Yeah, sure.
But it's a problem on the way to that stabilization. Right?
Yeah.
Because you're talking about
Depends
models
how
without
much-
a carbon cycle at all.
Yeah.
Okay.
An AR4 model,
Okay.
for
Yeah.
lack of a.
Sure. It depends how much freedom you give each model to get its own route to stabilization, right? I mean, I wouldn't propose doing that.
I think I like to put that out as something to discuss
Yeah.
when we get there. Because I think it is important. There's going to be probably only, there's something like 17 modeling groups. My
Yeah.
guess is order of half will have ESMs.
Yeah.
So if we design something for only half the modeling groups in the world politically, that's not going to fly.
No. No, and you don't want to do it such that all the modeling groups have to do it twice if they've got ESM components as well.
They won't do that either.
Well, stabilization is such a brilliant. Gets rid of all those degrees of freedom.
So,
So there's sort of it seems like there's sort of three classes of models. There's that class. There's the class that I was thinking about, sort of like the HAD 3 model or whatever, where there's a carbon cycle, but it doesn't include, a gridded land use that's consistent with emissions from land use. And then this new class of models that would be.
and I think we can anticipate what, say, the handful that will have the new models, what that new model will be. I think we can anticipate that in this group, and I think that's a good thing. I didn't want to constrain the discussion before when I said don't forget about the research ones, but I think we should anticipate what that next class of models is going to look like.
Just to clarify a point, with doing stabilization scenarios, you're saying that you wouldn't have to run an AOGCM without your carbon cycle to get a baseline simulation. Is that what you're saying?
No, you could run, we already do it, and you can run a prescribed CO2 scenario, even though you've got interactive fluxes calculated. Flux is essentially diagnostic, but completely consistent with your climate change. That means that you could choose not to calculate the fluxes, you could not have those components. You use the fluxes subsequently offline to work out what that implies for emissions. Okay, so bizarrely, we're going to, under this proposal, you decouple the problem a little bit.
Yeah.
Right?
But you wouldn't be able to make your nice plot showing the temperature change impact of including the carbon cycle.
You can still do that. You can still do that. I mean, you can diagnose it. You can certainly look at how the carbon cycle affects your emission scenario, your prescribed emission scenario for stabilization, which is a more important thing politically.
But it's a more complicated concept.
I don't know. I think from a policy perspective, it's much more relevant than the sort of, well, what if we do nothing type scenarios.
Yes, I think, like I said, we'll get to this.
Yeah, sorry. I'll just keep,
It's a good thing. Gotta wait till we get there.
But shall we try to run down the list?
Yeah,
And
that's
then
it.
return to this question?
Yeah.
No, you go ahead. You're more familiar with these issues than I am.
Okay.
I sort of reformulated that question for Richard's suggestion. What are the most important climate change impacts, mitigation, and science questions to be addressed? Trying to really fold the impacts and
Okay.
mitigation principles as well.
Yeah, for me, when I read that question, I thought of all those anyway. But
Yeah, it's good to make it explicit.
Good, we're making progress.
I didn't know you ever had to make progress with me.
Just to make it clear.
Okay, so what are what's the list of key questions that we want to address with the board?
Well, I'll throw an impacts one out, and I think I would frame it in the following way. Again, sort of focusing on a bottom line for policymakers, which has to do with bracketing for risk assessment, what kind of a best case for impacts and a worst case for impacts. And the best case might be defined by a scenario with low rate of forcing and relatively high socioeconomic capacity to adapt. And those two things, I would argue, in fact, go together because in general, an adaptable society is going to be one that has more resources available to it to, build seawalls or change crop patterns and infrastructure or whatever is required. And that society is also going to be one that therefore has, in general, a higher level of capital to invest in mitigation. And so you get from that to the lower net radiative forcing. So that's kind of just trying to simplify and cluster what could be, a very large number of combinations of socioeconomic conditions and climate conditions, putting that as kind of a best case. And then the converse, the worst case would be a case where you had very high radiative forcing and very low adaptive capacity. And again, those things could be argued on the same grounds that they'd be likely to go together. And so that would kind of demarcate with the least number of runs I can come up with, a best case and a worst case for somebody who's in the agriculture ministry or the water resources area or something, to think about, what's the range of things that I have to plan for, given that there's going to be uncertainty.
I agree with that. I think this is exactly the topic that we have been struggling now in the working group 3 in our chapter, is because there is now quite lots of emphasis recently on these very low stabilization scenarios, and it's very difficult to derive what is the residual climate change still left from the current runs in order to assess how much one can reduce the impacts and how much adaptation is still required. But I would agree with Richard, at least from the socioeconomic side, these low stabilization scenarios, I think everything else being equal, will be associated with wealthier and more adaptive societies, whereas the high stabilization or no stabilization scenarios would be probably associated, could be affluent societies, but they're more likely to be poorer societies with less adaptive capacity. So this categorization of +5 watts per square meter and 3 might be an interesting span to do at least two types of runs that would help assess the impacts and adaptation capabilities, and at the same time provide the leverage of understanding what the mitigative activities would have to be to reach the 3 watts. So I think that span would be an interesting thing to look at.
Okay. What else? Isn't one what's the role of carbon feedbacks in the climate change?
Absolutely.
Yeah. But is that also, would this big diversity of scenarios be also useful for that, to go for a very high forcing and low forcing from the carbon
I was
point
going to
of
say,
view?
at this point,
It's not clear.
we keep getting into the scenarios, and I'm not ready to get there yet. I'm just asking what's the questions we want to answer. So for here, all I'm thinking is, if you're going for runs to be made, one run would have interactive carbon and one wouldn't.
Well, I suppose if you want to put that into a question, the question becomes, what, you have to phrase it carefully. You don't want to overpromise. The simplistic way of saying is, what are the effects associated with different forcing levels from an impacts perspective? But I think, you can't, my feeling is you can't yet discern between, say, a 450 and a 550 scenario too clearly on the impact side what the effects would be. So, one needs to sort of, I think, fudge it a little bit and say, what can we say about the effects associated at different either stabilization levels or forcing levels or whatever, which gets at this key question that governments have, and you see politicians all the time trying already to say, well, we have to stay below 2 degrees C average temperature increase or whatever on the basis of some impacts work. That we lose the coral reefs or the polar bears or whatever it is at a certain temperature. So it's that kind of a question where you try to work towards associating particular impacts with particular rates and levels of change.
Okay. That's one whole set of questions.
Right.
What other questions we want to look at?
It seems like there's a whole set of questions which are sort of the same as the questions in all the previous IPCC assessments. Just presumably these models are providing those calculations, but hopefully better. Right? So you want to know what the climate change is as a function of any one of these scenarios, and it's going to be different with this new class of models than it was with the old class of models, even if the scenario is the same.
So you're saying comparisons with some of the older generation, right?
Yeah, maybe some kind of I don't know how to phrase rephrase the question, but some kind of demonstration of how this added model complexity is.
Well, sure. I mean, in a sense, previously, with prescribed concentrations, you were looking at the question, how does the climate change vary with the concentration scenario? And now, with the coupled system, you're saying how does it vary with the emission scenario, which is a much more useful thing to be able to discuss, actually.
But then George's question, at least with my interpretation of what George's point was, then you also kind of want to know is how you relate those newer models, if they were run in the same manner that the old ones were run, where you're taking out the inactive carbon, how do those answers compare?
I mean, just the added Earth system model complexity per se, how is that changing the...
Does dynamic vegetation do anything?
Do anything in the long term?
Or
sure.
sea ice, if that's
I mean,
in there.
Or sea ice changes, or the new convection schemes, or whatever else is going into the models.
Yeah, I mean, I think what
Higher
routine is
resolution.
done. Sure, I mean, if you put in a new component, then you certainly want to do a control on to prove to yourself that it mattered.
No, but I think that's true individually, but I think between the TAR and AR4 and AR5, we want to be able to show what the differences of the physical climate models are.
So maybe there'd be some subset of runs that try to do that.
For example,
experiment.
in the AR4, we have one scenario that was common with the TAR, just so we could do that comparison.
Yeah.
Yesterday, I'm just curious, when you were talking about adding all the different components, was there some discussion of adding one at a time, doing different runs with just one thing added and then a different thing added, or is it all going to be multiple changes?
Came up, but then Ron's response was, "This is going to put together. They're going to be made way too many runs." And
for a core, I mean, the individual groups have to do that, but we're not going to be. The IPCC won't be comparing.
Would it be done through one of the comparison processes?
No,
Interesting.
it'll be built in a way. Because each group, the path each group is going to take is going to be different.
Right.
But it does seem to me that it's worthwhile maybe isolating a few. If you could identify some sort of fundamental questions that this would answer, then it would be worthwhile doing those kind of calculations. You can't explore every new variant that has gone into the suite of models.
Well, the one I was thinking was just the grand one, is turning the inactive carbon on and off.
Right. That's good.
That's one of those kind of runs. And also allows then, if you turn it off, that allows comparison to the AR4 models. Because that's what an AR4 model is.
Right. That seems really important.
But there's a third run, right? You need to diagnose the climate carbon cycle feedback, which is not the same as prescribing CO2. It's actually equivalent to making CO2 a non-greenhouse gas as far as the carbon cycle is concerned. So you're talking about 3 runs.
Just making a tracer.
Yeah. Well, the increment in CO2 can't change the climate as far as the carbon cycle is concerned. Okay, that's the diagnosis of the carbon cycle feedback. And then there's an issue about making contact with prescribed CO2 scenarios, and you just have to run another one.
Right. So just to be, the purpose of doing the carbon cycle without its radiative feedbacks is what?
Just to show the climate, well, the effect of closing this feedback loop.
Uh-huh.
What's the effect of
just
climate?
to show the feedbacks per se.
Yeah.
We'll show the difference, basically, right?
Yeah. Of course, if you use prescribed CO2 scenarios, you can diagnose it. Anyway.
Yeah.
I hadn't thought about that third run.
So I'm not sure I understand that because I thought Ron's experiment did that. Ron's experiment was don't include the carbon cycle at all, or include it in a couple.
How do you know? The problem is, how do you know what the carbon cycle would have done in the absence of the feedback? Because if you're prescribing CO2, you don't.
I see.
Although, again, and I hesitate to do this, but if you do have a prescribed scenario of concentration, then you can potentially diagnose some of these things.
I see.
So you still run coupled with a prescribed scenario. That's the way to do it.
Yeah, that's what I was a prescribed concentration scenario.
Yeah, and then what you do is you compare the models in terms of their diagnosed emissions.
Yes, that's what I was thinking.
And that's equivalent to what I was proposing with the stabilisation, but you could do it with another concentration scenario. You could do it with IS92A or SRS82 or V2 or whatever, couldn't you? You do the carbon cycle interactively, but it doesn't change the CO2 concentration. You therefore diagnose the consistent emissions with that.
Yeah. Would we only have to do that with one of the scenarios? So if we pick say A1B. We have concentrations for A1B now that we've all used in AR4.
Yeah.
Except the emission scenarios have changed for A1B, right?
No, not really. That's a low population that
So if
stays
we
more or
did
less the
that,
same.
so if we ran a run where we used those concentrations and then made another run with the interactive carbon with
Oh, you mean you make your own concentration scenario based on the emissions?
no, we already have in the AR4 there already is an AR4 A1B concentration scenario.
Okay. Which everyone's using.
Which everyone used.
Right.
So if in AR5 we use that one again,
Yeah. Sure.
and then use the emission scenario, then we could do the delta and see what the interactive carbon did. What am I missing?
If I understood it correctly, you would replicate two types of emission profiles that are consistent with that concentration. One with feedbacks and one without.
Right. Although the concentrations
Well,
in the emission one won't be the same as the concentrations in when you're prescribing it. But that's because of the models, the interactive carbon cycle that you're predicting.
And one thing you don't get is an estimate of the carbon cycle, the feedbacks on the carbon cycle. You wouldn't get that. I think that's what you're talking about.
If you do the calculation he suggested, where you treat it as a trace gas, or a gas, but not a reactive, then you know what the a given emission scenario is going to produce and what the concentrations.
That'd be the effect of the
That's interesting.
increased
Could you do a
CO2
double
in
radiation core?
vegetation.
Yeah.
But
On a
that's it.
single run.
But it's expensive.
But is it more expensive than running two runs?
Nowhere near as expensive.
So you could see that as part of the experimental design, right? Just that you always run with climate effects in the carbon cycle, but you also run a second radiation core and a second carbon cycle core, where CO2 is just the extra CO2 is just a tracer. It'd be an absolute nightmare, but it works.
I'm not sure what the experimental design is. I'm understanding what you're saying.
Well, I'm saying.
But we're going back to
Questions?
the questions. We keep going to the scenarios.
I don't think you can do
I think
don't think you can do the questions about the scenarios. I think the scenarios are all the questions.
Okay, so why don't we give up on that then? We'll just do them together. I'm willing to buy that since experientially it seems to go that way. So if we do that, we kind of talked about the models a little bit. The only thing we didn't talk about was emix, the role of emix in this.
In red.
In the core. This is the question number 2 that they asked. So what models, AOGCM, ESMs, and...
We're not done with one yet, are we?
Well, I'm going to
Because I have other questions.
No, I guess
I'm just trying to keep quiet.
well, since we were mixing 1 and 3 all the time, or in almost 4, I was going to try to do them more holistic.
Geez, maybe we can quit at the coffee break.
I was trying to be more holistic and then say, is there any other things about the models we need to discuss? Because there was the proposal for this, what the core model would look like.
Yeah. So I think we need more. So you said one of them, but I think we need more things to show how this new core is different than the previous core. So I think we need runs that show, what's the effect of land use, on these climate change projections. And that's going to be a new thing in the model. So let's do runs that
I
illustrate
think
that.
that high resolution type of question would emerge in the short term runs.
Yeah.
I
I'm
think
not sure that the models will have the computational ability to run 200 years with an interactive projected land use. I'm just trying to keep the focus on the long term.
Yeah, no, I think we're planning on doing that to 2100.
How about 23?
How about 2300?
I don't know about that.
Yeah.
21 and
Because
beyond.
I think one of the motivations
Well,
for
stabilization
this post
scenario for
2100 is also to look at how might we invoke the models that do long-term calculations like EMIX. What's going to happen to Greenland? What's going to happen to high latitudes? What's going to,
Right.
and I'm not sure that this high resolution the models just simply won't be able to do the tiling necessary.
So I think it gets easier for what Steve was saying. I think it gets easier actually past sort of 2300 because at some point you've used all the arable land. I mean, it's like I think there's a lot of uncertainty how we're going to use all the arable land, but eventually by then we will have.
I'm thinking more in terms of
So it won't matter
other
anymore.
computational costs associated with chemistry and aerosols and that sort of thing that are going to be associated with agriculture, burning, and that sort of thing that goes into land use.
Well, I don't know exactly what you were saying, but with some of the land use scenarios, land actually gets returned back to the nature, like what's happening in North America and Europe to an extent today already.
Well,
So they have perhaps similar net emission profiles from land use, but for different reasons. In one case, because you are curbing the agriculture, and the other one because you're exhausting all of the potential agricultural land. So I think there is some bifurcation there.
Well, that's good. Can I restate my question? And also the other big difference it seems like in this new core of models was this interactive biology in the oceans. I mean, I think we need to illustrate to what extent that is going to help or hurt stabilization.
And that strikes at the heart is the carbon cycle positive feedback. And if so, how big?
Yeah, right. I guess these are sub questions of your question. But I'm not sure you can do that. Yeah.
And I think in talking to oceanographers, it's the ocean biology that is really does impact the longer term frames. It's the physical air-sea exchange and those physical properties of salinity and temperature that are very short-term processes, whereas it's the long-term processes are primarily governed by ocean biology and biogeochemistry. So that's those sort of simple ecosystem models that might be going into the ESMs that might be a good question for a long-term one.
Does it go beyond the carbon cycle issues?
It's linked.
It's linked.
It's linked. It does actually.
All those questions seem really good to me, but they seem outside the core.
Well, if some of the core were to include simple ocean ecosystem dynamics, then that would be a comparable question to ask at the level. If you're asking what are the implications of a carbon cycle, you might want to tease that carbon cycle into land versus ocean.
Yeah. Oh, for sure. Yeah.
And I think a
Pictures like
policymaker
that
will be interested in that too.
Yeah. No, I didn't say I misinterpreted what you were saying. So when you said long time scales, I was thinking paleo.
Yeah,
But
that could too.
But the paleo.
Hundreds of years, 2,300.
But I think paleo is outside of the core because you're just not going to be able to run AOGCM somewhere.
But if EMICs, we had 3 EMICs in AR4.
And there were no EMICs in the core of the AR4.
Okay.
EMICs were used either in research parts of the AR4, that's to my knowledge, and then they should have been used, but were not, to actually make projections to fill in what the AOGCMs didn't run. Unfortunately, they didn't get the community organized in time to do that, but that's what they wanted to do. So they weren't actually part of the core.
But don't you think for AR5 they would be a part of the core?
I think that EMICs could be part of the core, but the core will be what the AOGCMs can run, not what an EMIC can run. That's how I would define it. So if an EMIC wanted to run an AOGCM scenario and be part of the core, it'd be welcome to. So that's how I would turn it around.
Okay.
I wouldn't design a core to be an EMIC, because if you would, you eliminate all the couple models, and we wouldn't have anything to do.
You could do your own science then. I would think you'd love
Politically, that wouldn't fly. It would politics will raise its ugly hand, and our funding would all disappear.
I assume that there's another set of questions there that's related to abrupt change, right, that would be addressed. And that's really going to be on people's mind. And then also another one related to sea level rise and the trajectory that you might get there. That if you're listing out questions, those are key ones to include.
They were kind of what George was saying. That's all the stuff that, I guess, that we have now. So all the questions we've addressed or wanted to look at in AR4, we're going to look in AR5. So then there's going to be another set that has to do with the carbon cycle. So I was more thinking, what's the new questions? But it's good to think about what if we're asked all the right questions in AR4, and can we ask them better?
I mean, I know one question that'll be, again, a cross-cutting question that wasn't so prominent, I think, in AR4, although I could be wrong, has to do with the topic of this snowmass meeting yesterday and today on looking at biofuels, and thinking in particular about the climatic input into those, both from a long-term secular change as well as a variability, over time. And the question there, of course, is if you go to that strategy, in part to make yourself less dependent on what's now seen as a risky fuel source, Middle Eastern petroleum, and obviously for the GHG motivations, and you're putting putting a lot of emphasis on biofuels. How secure a strategy is that, given that you're not dealing with a stationary climate? And what would be the climate considerations that you want to think about in designing such a thing? And that's, realistically, I think after the discussion yesterday of the infrastructure and network requirements for really ramping that up, I mean, you're not, it's something it's a relevant question for the time frame we're dealing with, the second time frame.
It is. You think it'll make the core?
Well, I don't know if
And
it makes
how-
the core, but it's a key policy question I'd like to see in a set, and then you can figure out whether it's in the core or not, but I'd like to see it on the list.
I don't know how it can make the core, because it comes in. No, I'm serious.
Well, so then we
because
just have to tell the politicians that they can only ask questions in the core.
No, they can ask whatever they want, but we can only answer what we can, right?
Is that a question that can be? Some of these questions, it seems like, can be answered at least to some extent offline. So, I mean, couldn't you take one of these climate projections and then run it through your best ecological model of how these biofuel crops, their temperature and climate dependence, and show that what if that climate change scenario unfolds the way it says it's going to? We have a problem because our biofuel crops won't.
But it would seem to me that that's related very much to the previous question of the carbon cycle, because when you're doing massive biomass, you're not only changing the nature of the agriculture, you're changing the nature of all of the land use. Because, I mean, providing, we have done scenarios of trying to provide 80% of global energy in 100 years with biomass. You basically have an operation that's at least as large as the agriculture today.
Yeah, it's exactly tied to that question.
Do you agree that some part of some part of that question could be answered offline?
Right, so long as in your experimental design for what's there, you've thought through what are the things you need to do that in a reasonable way. You have to have a spread of scenarios, and you have to have,
And would that mainly come in through the land use and emission scenarios into a GCM?
Well, I mean, presumably that one can envision that that's a future scenario that has the biofuels as a key part of it, and agricultural land increasing in the area dramatically to sustain that. But then it seems like offline you could then take even more advanced sort of ecological models that really simulated how these particular biofuel crops depend on climate change and evaluate through its same area.
You sort of assume that it won't feedback on the climate, right? It could.
Yeah, so
Yeah.
Something very massive.
Yeah, it's
You
best
can
to do
send
it for a
me
couple,
also
but
some of that offline,
think.
You need some online simulation as well.
I guess one could do that offline, because the information in principle should exist. Because, for example, B1 scenario had this kind of agricultural assumptions in it, whereas the other ones didn't. So
I mean, sort of much
could
like
look what the difference would be.
we do lots of like forest ecology research is done offline, where we take these climate scenarios and then run them through our forest ecology models and predict massive changes to forests in the future. Now that's uncoupled because those changes obviously weren't in the climate run. So it would be a research agenda like similar to that.
clarity, you're saying that some of the climate simulation already have
No, some of the inputs, some of the scenarios, like B1 scenario, has huge amount of biomass in it for most of the models already, for the emission models.
Okay, but not every climate model has used that information.
But some have. There are some B1 runs. So now all I'm saying is that in principle, maybe we do have already some of the information to run the other to see what the difference would be if you account for the biomass effect.
That was a question that you were asked last night, Peter. That specific question about.
Yeah, there was a guy who was in the business of biofuels. So I gave the right answer, which is basically saying.
What? I'm sorry, I was not there last night. What was the question?
He was saying, what do you think about using land for biofuels rather than? I can't remember what it was.
Yeah.
Well, there's some kind of trade-off, right?
But yeah, between forest sinks versus biofuels.
Forestry via biofuels, yeah.
Has anyone mentioned timescale issues for stabilization? When you're using ES system type models, the stabilization of emission and stabilization of concentration are different things. And
Right.
wouldn't it be interesting to ask how long it will take to stabilize concentration after stabilization of emission? And what determines the time scale?
Well, I guess that's already the question number 3. Shall we move to that?
Yeah, why don't we get into that?
I think some of those issues are already tackled in the current emission scenarios that you're raising. Like the question is how that looks from the climate modeling point of view. Because for the low, I've shown that day before yesterday. For the low stabilization cases, the emissions have to peak within the next 10 to 20 years, unless you go for the overshoot strategy and then more massive reduction afterwards. And for the high stabilization levels in our studies, emissions can peak over the end of the century, so there is much more time.
Then it'd be also interesting to ask what impact does feedback
have on that, exactly.
For
That was
determination of
Yeah, okay.
timescale.
Okay.
So for the emission scenarios, are there obvious candidates for what Richard's first point was for the best, so-called best and worst case? We have a low emission.
Yeah.
What are those?
Well, I think that the worst case is clearly something based on the A2 type of world. It's,
Well, I thought that what we talked about, even I don't remember if it came up in the report from the Seville meeting or not, was the idea that the IPCC would kind of only specify basically as much has been said: low forcing, high adaptive capacity; high forcing, low adaptive capacity. And that would be, I mean, the idea was that somehow was going to be enough for the climate modeling groups to go ahead. But I think that's clearly questionable now, although maybe not, if you're doing your own land use. And then the emissions, or the detailed socioeconomic stuff, would be done in parallel, so you didn't have to wait for it, nor did you have to tie your model runs to socioeconomic detail that's very open to criticism on different grounds.
I think that's correct, Richard, but my concern is slightly different because there is a huge now overlap in the models, namely that on both sides, on the emission side and on the climate side, you have carbon cycles emerging into it and the land use as well and the feedbacks. that's being covered in both approaches, I think it would be good to think of a more precise specification in the following sense. Let us just assume it's an A2 type of scenario we are talking about. Then it does make a big difference if it's an A2 scenario with lots of biomass or little biomass. That's what I was trying to say.
Right, I guess the only question I have is from the point of view of the politics of the IPCC process, whether that's going to be permissible anymore.
But I mean, this community can talk about it, because I would say, let's take another issue that I think makes no difference, is irrelevant, is how high is the population. For the climate modeling, that really doesn't make any difference as long as some information about the land use
Right.
is provided.
Yeah, no, I mean, that's the point in a way, that from a socioeconomic perspective, there's an infinite number of combinations to get to high forcing.
Exactly.
These guys don't need to worry about which combination, because once you pick one, then you're subject to the criticisms. What do you mean population is going to be that high? Or what do you mean GDP will be that low?
But I thought that these different high forcing scenarios had different trace gas amounts.
Yes.
And if they,
Well, that's the key question.
That's right.
and then once you have different trace gas amounts, the amount of CO2 is going to matter for the vegetation.
Well, Naki, what would you think of the following assertion, that if in the high forcing case you'd likely have, for example, higher aerosol?
Well, unless it's, of course, a biomass scenario, because then you might have different aerosols.
Right, well,
But I mean, the way the things
complicated.
stand now, I would say in literature, with, of course, there are always big exceptions, but a kind of a high impact, relatively poor world with high emissions or high radiative forcing is the one where there is lots of coal being used. You know, China, India, but even in the north. And if it's a fossil intensive scenario, I think that's very likely to be such. Then, of course, then one has to make some assumptions whether there would be sulfur abatement and what do you do with the other pollutants. That's a scenario function. But I think there has to be some common understanding of what that could be, because it makes a big difference for the climate.
In this this A2 type of world, it seems like another thing is that the so that's the world in which we sort of burn as much fossil fuel as we can get our hands on.
Well, because we don't have enough capacity to invest in anything else.
Right, and because there's plenty of it, yeah.
Right, but that's a case where it would seem to me unlikely that there's a lot of land being converted to biofuels. I mean, it seems like people aren't going to bother with that if they're content with fossil
I
fuels.
agree with that. All I'm saying is you cannot exclude a scenario of that sort where there is also lots of biofuels. You cannot exclude that, because there are parts of the world that are not so well endowed with coal, and they might be using domestic resources. So I think it's a possibility of a variant.
Well, but again, just the motivation here is to make it as simple as possible and as few runs as possible for the climate modelers to come up with some kind of an approach that gets you the information you need at the level you need it without tying you to detail you don't need. Because, right, you don't, I mean, from your perspective, a lot of the detail in the SRES scenarios wasn't not necessary or relevant to your work.
All I want is a time series of trace gases.
So that's the question: is how do we get that without tying you down or slowing the process down?
And my feeling would be that this kind of scenario, if that's what we are talking about, would have high trace gases, both high CO2, high trace gases, and perhaps even high methane.
So it is possible, in your opinion, to do that kind of two-track process that was talked about at Seville.
Yeah.
There's a slide, actually, that illustrates it. I don't know if you have it on your computer. I may have it on mine, that diagram that shows the two.
With the timing?
Yeah, this is something that came
somewhere.
out of the TGICA. John Mitchell had kind of proposed it. But right now, the sequence is, I mean, for the, you know, we had a long process, what was it, 2.5, 3 years for the SRES, and it was only at that
It was
point
more like 4 years.
that you could start the climate modeling off that. If we do that again, the goal of having an integrated set of climate models based on new emissions scenarios by 2013 is already impossible. So you have to try to break apart the two streams of doing the detailed socioeconomic scenario modeling in parallel with the climate modeling rather than sequentially. And so what we're trying to do is see if there's a way to get to the detail you need on the trace gases without tying it to a lot of socioeconomic detail. So it's sort of the idea of stylized scenarios on the emissions side that, and the emissions modelers back the detail into while you're doing your runs.
I would suggest, I mean, I think Peter made I think it was you, the day before yesterday, this suggestion that one could think of climate models coming first this time rather than the other way around. Agreeing on some kind of, what do we call it, couple of core runs, benchmarking, and then the scenario community could go back and refine their emission scenarios as a consequence, precisely because of this overlap, because the emissions community already has to do inverse calculations in some way, because we, to a large extent, specify either concentrations or the forcing and optimize within the whole framework how the development path looks like that's consistent with that. And so one can think of shortening the time frame by doing first this kind of benchmark climate runs, if we agree on in which region they should be, and you already made some proposals. And then I think the scenario community can react to that by providing the development paths. And that's probably a shorter process than doing the climate runs. So I think one could compress the time scale quite a lot that way. That's consistent with Sevilla, I think, anyway. It's just this idea that climate runs come first. It is at least new to me, and I find it quite attractive.
But then who develops those scenarios? Making sure that things like the land use is consistent with the scenario.
Yeah, that to me is well, I don't understand how. I mean, the new scenarios are going to have to be more than. You seem to be saying that to avoid sort of criticism of details on the socioeconomics, we want to try to get away from those details and somehow just make scenarios of ideally just watts per meter squared or something like that.
Well, but obviously you need more than just watts per meter square. I understand that, and so the thing is there a stylized set that you could say with a high forcing measured in watts per meter square? Is there a stylized set of the other gases and short-lived species that you could associate with that, and then the socioeconomic teams could kind of inverse model to that?
But
just to finish my thought, the one thing that I see the scenarios going in the other direction in this new generation of models is going to need gridded land use information that's consistent with the emissions from land use. And so that's going to be a whole new level of detail that actually the scenarios and the models need. It's like a step in the opposite direction.
But they need that for initial conditions, right? Because then doesn't the pattern come out of the core system model?
No, it's
going to be forced.
Not how you force the land use.
Well, I think if you to do it properly, you need what we always needed, about 10 years. So I think that the issue is here, can you short-circuit the process in such a way where we don't lose too much of this information?
Yeah, I'm with the goal, I'm just...
What's your... What you have to have... You have to have, first up, you have to have an idealized set of scenarios, probably stabilization scenarios that have associated with them approximately consistent land use scenarios, right?
Yeah.
Then you run it through the models.
Two land use.
Sorry?
You could probably explore two scenarios for land use.
Maybe,
for
sure.
Yeah, maybe.
Yeah. So then you run your ESM and you get out diagnosed fluxes. We give them back to you and say, well, does that work? Right. I mean, that's basically what we do. Is this feasible?
Exactly.
And what are our options to stay on that relative forcing stabilization curve with these diagnosed fluxes?
And I would argue that...
I think you iterate that?
Sorry?
Then you iterate that? No.
You could. I mean, I suspect you wouldn't need to.
Yeah, right.
I suspect you wouldn't need to.
I'm just trying to complete the logic.
Yeah, no, I don't. I suspect you wouldn't need to, because I think that the feedbacks are not so strong, given that you're running a radius forcing scenario, that you would have to massively modify your initial scenario.
But I mean,
it just turns the thing on its head, and you start to think about what you have to do to reach stabilization rather than what we're currently doing, which I think is not so useful politically.
There is an implicit iteration here, because with this process we would start with a limited set of scenarios, then we would have this benchmark climate runs with feedbacks, and then we would revise the original emission scenarios.
Sure.
So you have at least one feedback, and that way I think you avoid this problem that the climate runs take such a long time and so many resources that you cannot actually do twice. We cannot have feedback on the climate runs, the iteration, but I think it's conceivable to have an iteration with integrated models. Because, you know, I think integrated model community can do it on the time scale of 1 or 2 years.
Yeah. Well, that's what the question I was just
Yeah.
going to bring up. Even in this scenario that we were just talking about, the GCM runs will be done about at the start of the IPCC process, so maybe after the first lead authors meeting,
Yes.
like they were this time. You know, the timing is going to be a problem. 'Cause
Yeah.
the working group
Why
3
is it
folks are going to get really
before?
squished.
If we've got this expert meeting on this technical report going before, you know, fine.
Exactly.
Why do you have to wait the start of
The expert meeting will be what, 2007, 8,
No,
something
because
like
they
that?
need the inputs
2007,
from the
somewhere
GCMs.
September.
Yeah, but we can start with GCM run after that technical report.
Yeah, because
GCM runs won't be done until close. I mean, the timing that most of modeling groups are assuming was similar to the timing that we just had.
Yeah.
So that the models will be run in 2009 and the results published, in a sense, on the web.
I think the reason you hear a
2010.
difference with Olivier is the Met Office, unlike so many of the rest of us, may have a fixed model much earlier on.
They
so
might.
they could do runs before many of the others.
Yeah, some groups can do runs now.
So in some sense, we have a flexible timeline because some of the results might be coming relatively early, some late, like 2010, and then the scenario community would have to somehow accommodate for that.
Yeah, but it's the limiting factor is the initial idealized scenario to drive the GCM.
Well, that was
Yeah,
the
but
question I was going to
I
ask.
think that we already have those in rudimentary form, and up to the next, when the meeting comes up, I think we would have to generate a common understanding. But the proposal that the working group 3 made to working group 1 is still in principle on the table. I mean, with modifications and everything else. But that set of scenarios is already on the table. So the question would be that you guys look at them and see how you feel about
Is
it.
there any possibility that the working group 1 and working group 3 will be more staggered next time? There's no chance.
I think it would be desirable, but I can't
We
imagine.
pushed for it for 2 cycles
Yeah.
and haven't managed to get it, but I
It
think
never
maybe
goes
it's
through.
time for the science community to revolt,
Well, they're staggered now, but by 3 months.
It works so much better
which is
if it
really
was-
helpful.
It would work so much better if it was like the World Cup and the Olympics, wouldn't it? Every 2 years you get some entertainment.
Very good. Well, but this scheme would argue for an earlier working group 1 report and a working group 3 report,
Yeah.
rather than the other way around.
Sure.
Yeah, because,
Which makes more sense in
Yeah.
a lot of
Right.
But
ways.
it is
And
starting
working
into a
group 2
process
would
that
be
goes from one
also later.
one
And that's-
assessment to the next,
right.
isn't it? When you do this
Yeah.
kind of leapfrogging, you can
Yeah.
see if you actually stagger them, you could do it that way.
Oh, I think that would be great.
We might converge on something in about 10 assessments time.
You mean by
Do you want? I would
AR
say,
16 or what? was
is
it?
this? I guess we can make such a recommendation, and it'll go up through the WGCM and AIMS.
I think
So I think that's a worthwhile
I think we can
2
discuss
year?
that. Yeah.
2-year
2
stagger.
years staggered.
Between working group 1
One,
and 3,
yeah.
and then
Yeah.
2.
Well, 2 and 3 could be at the same time. Is there any
Or you could
feedback
have-
There
there?
Yeah, one-
should be, I mean, increasingly there need to be, because of this issue of trade-off between mitigation and adaptation and
Well,
things
and
like
actually, 2,
biofuels.
isn't it true, Richard, that 2 would need input from both 3 and 1 in some sense? I mean, it's all
But you can also
interactive.
argue that 3 would need the
Yeah, I
input
guess
from
there's
both
a cycle.
2.
It's interactive. The question is just what is a stronger dependency, because the impacts depend both on the socioeconomics, as you've said before, and the climate. Whereas in group work in 3 that works on mitigation, the residual impacts are relevant, but climate is more important in some sense in the first approximation, because we choose stylized levels of mitigation,
Right.
not ones that are based on adaptation and impact that we calculate ex post.
Right, and I suppose you could put some of what you're concerned about in terms of impacts on biofuel strategies of climate
Yeah.
into working group 2. It'd be a little messy, but you could do that. The diagnosed fluxes that would come out of these initial benchmark runs, I assume that those are time dependent because they're fluxes, but I also assume that there'd be a lot of variation across models. And so just from the point of view of then saying to the emissions community, is that reasonable? How does that work? Do we end up running a lot of different emissions models to fit each GCM style, diagnosed fluxes, or I mean, I'm just trying to think through the implications of the variation.
You could do the same idea where you have a best case and a worst case. Take extremes and a multi-model ensemble in the middle. I'm not sure how you determine the best and the worst case, but it's certainly multi-model ensembles tractable.
So can we just talk through this idea one more time, because I'm not sure. I think I'm
Well, it's not an
focusing
easy idea.
on it. The idea is that there's some initial scenario with gridded land use or whatever that's created.
Yeah. Well, what the working group. Let me just. I've said it day before yesterday, but it was too quick. If I may, let me just repeat it. There was last year a proposal between working group 3 and 1, based on the current literature, to define a small set of socioeconomic development paths and the resulting emissions, both on the baselines and on mitigation, as a possibility for the climate community to do some new experiments. That was the idea. We had a series of teleconferences between working group 1 and 3. We had agreed on the time scale and so on and so forth. And as a consequence of that agreement, working group 3 produced a small set, let's call them, of illustrative scenarios for these different stabilization levels, baselines, and the 3 different stabilization levels: 3 watts, 4.5, and 5 plus. So those scenarios in principle exist. Some of them have gridded land use, others might not. But that was always the reality. Then you have to somehow share.
Were those based on the SRES? I can't remember.
No, only partially. I mean, I can show the graph, but let me just say what I remember. It's based on new versions of some of the SRS scenarios, plus multi-gas mitigation, but it also includes non-SRS baselines, like the MIT baseline.
And it includes climate feedbacks and some kind of offline climate model thing?
Well, I mean, many of these integrated models have feedbacks built into them.
Okay, yeah.
So, I mean, it's the current state of the art of the emission scenarios, But that set is, as it stands, probably too large for climate benchmarking, and that is the step that we never completed because we had abandoned that strategy beginning of this year. It was, I think, felt on the working group 1 part that it was infeasible for this cycle. Okay. But that doesn't mean that we cannot use it as a basis for the next cycle. Okay. And so one would have to revisit this idea of this scenario set and probably choose a limited set that would be useful for benchmarking.
There were 5 stabilizations.
There were 3 stabilization levels. 3 watts, 4.5, and 5 plus.
So what's the relationship of those to the A2, B1, and all those guys?
Well, A2, I have to open the file. I don't remember all of those things.
The point is that they may serve the purpose of
let me look what the scenarios are then.
Scenarios to go into the benchmark.
Yeah, so can we just talk through
one of the things should be that one of them parallels at least one of the previous ones.
Okay, that's
all. So let's say you have
but it's an updated version of the previous ones.
Well, the question is, can you limit the updating enough so that it's that the GCM modelers can say this is, et cetera.
Well, what we really want is the concentrations to be the same.
Right.
We don't want the emissions to be the same. We want the concentrations to be the same.
That we ought to be able to.
I don't think the concentration is a big problem. Let me just see which cases they are so you can be more specific.
But once you have that, then what? Then you're saying climate models spend their time, working group 1 models spend their time doing those.
Do some subset.
Some subset of that.
In this benchmarking process.
Well, I was going for Richard's idea of the high and the low.
Right. In theory, you could do that.
You do 1 high, 1 low.
Yeah, so I think we had, as far as SRES set is concerned, the scenarios were based on the A2, B2, and B1. But there are updated versions. And then there are some new scenarios that were not originals. They were not part of the SRES, like the MIT group.
But then were we saying that after these working group 1
models run.
run those, then information goes back to working group 3.
Yes.
And they make up the
And they revise this
story.
original
Revise it as appropriate.
They revise the
and
scenarios.
produce new variants, which is the new information, right?
Yeah.
Because there can be multiple paths that are still consistent with the climate trend.
And the question is whether we run the Earth system model again, or whether we just do it with MX object from the new set of conditions. It might not have put time, so we run.
No, you won't run the AOGCMs again. But
That comes really ahead of time. It's supposed to be good.
The purpose of creating these new scenarios from working group 3 is that the stabilization scenario might not actually be stabilization. And these,
well, I'm curious is
why do we go back to working group 3 then?
it would have to go back. I could believe that they wouldn't be, or there could be.
Yeah, right.
Right.
But that's the
time
purpose.
scales.
They can be completely unanticipated problems.
Yeah, right,
Don't
right,
forget
I got
that
you.
we arrive stabilization through very, very,
Very simple, yeah.
simplified
I got you.
In some models
approach.
they might be,
Yeah.
some models they
Yeah.
couldn't be.
No, I agree.
Because of all of that.
I have to look in detail, but I think there were A2, B2, and B1.
Oh, and B1.
Yeah, but I'll have to check that, yeah?
What would you say again?
A2, B2, and A1.
But similarly, these revised scenarios that come out of might not, then in principle you have to put those back in the Earth system models, and they still might not be stabilization because something else might happen.
So
Right.
A1 is
Yeah,
the
so it's an
3.
infinite loop.
Well, yeah,
A1 is the
but if
3.
you had a staggered assessment process, that would
No,
just be
the baselines are higher than from all of those three baselines. You derive the various stabilization levels. We had idealized combinations of what made most sense.
Just keep going back and forth.
And you do that, but you don't do it in one assessment.
Yeah.
You do it across the
Yeah,
assessment.
take a break for about 10 minutes.
Okay.
Why don't we come back at 10:30? It's about
10:20.
10:20.
I don't think there's any guarantee of convergence.
Quite exciting.
Because meanwhile the models are changing, right?
They set all of Aspen's down.
Well, it was up for about 10 minutes after she said that.
And then it went down. Was down also the day before yesterday.
For a little while.
I- I-
Yeah, it was a little while, and then it came up.
No,
You're out
it's
in the middle of the mountains.
Yeah, that's
it.
well, actually, one shouldn't have any connection to the internet.
Sorry?
Would improve the quality of life.
I've got like